Good evening, students. Prushti sir again with two easy but crucial questions for you. I am calling them quiz questions on rolling body constraint and relative velocity. First will be the relative velocity concept, relative motion basically, it will be motion concept. Okay? These are my credentials. Important thing to note because of this some of you are able to contact me and ask different questions, and the questions I'm going to discuss is because of the some of you have raised these questions to me. I'm discussing two questions. So the important obviously, and for you those who have asked me this, they must be thinking that it's a good question, and which is actually true. So quiz one, see the diagram. This is the horizontal plane. These two are to AB and CD are two rough inclined plane. Coefficient of friction is mu for both the planes with respect to the point object which will be sliding on them. The point objects are marked in red, 1 and 2 here. It will really, point 2 is released from C on CD plane, and point 1 is released at A on AB plane. Simultaneously they are released. AB, CD are two inclined planes making angle theta with the horizontal. The two both are making same angle theta. 2 point particles 1 and 2 are released simultaneously. Same time they are released from A and C respectively on the inclined plane AB and CD. See the diagram above, which you have seen earlier, shown you. Okay, the coefficient of friction between the particles and the planes is mu. Normal symbol for coefficient of friction, and mu is less than tan theta. If mu is less than tan theta, then sliding will take place. So both will slide down with accelerations. Simultaneously release, that's very important. The particle 1 and 2 take time t1 and t2 respectively to reach the ground. So particle 1 reaches the ground after t1 time. Particle 2 reaches the ground after t2 time. Obviously t1 will be greater than t2 because this is smaller length, this is larger length, same inclination and same mu. Okay, am I clear? Is it okay? What is the question? After what time t naught? After what time t naught? After release, will the particles be closest to each other? रिलीज टाइम का कितना टाइम के बाद दोनों के बीच में जो डिस्टेंस मिनिमम होगा, दे विल बी क्लोजेस्ट टू ईच अदर. दैट टाइम आई एम टेकिंग टी नॉट. आफ्टर व्हाट टाइम टी नॉट? आफ्टर रिलीज the particle will be closest to each other. That's the question number 1. And also find the closest distance. The two things. This is basically relative concept. Solution, let us see. Since mu is less than tan theta, both particles will slide down with acceleration. Yes, sir. Almost very clear. Okay. So what is the acceleration of each of them? G sin theta minus G common, G sin theta minus mu G cos theta. All of you must be knowing this is a very simple concept. With the friction, inclined plane having friction, the inclined plane, down the incline, the acceleration will be mg sin theta minus mu mg cos theta by m. So that will be G sin theta minus mu cos theta for both of them, because theta is same for both of them. Both will have same acceleration. A1 will be equal to A2. magnitude is A, their magnitude of acceleration down the incline will be same for both of them. Now let us find A12, acceleration of 1 with respect to 2, that is A1 minus A2. देखते हैं, ये है आपका A1 vector down this incline, this is A2 vector, minus A2 vector means opposite direction A2. That's both the, this is minus A2, I've written here, red letter. A1 down this, both same magnitude. So if this is theta, then in this triangle, this is 2 theta, external angle. Okay. If this is 2 theta and this line is parallel to this line. So alternate angle, these two are equal. If this is 2 theta, this is 2 theta. And these two vectors are same magnitude. So the resultant will be bisecting 2 theta. This will be theta, this will be theta. Yes or no? If this is theta and this is theta, so this will be parallel to the horizontal. So A12 will be a vector parallel to the horizontal plane. A1 minus A2 vector is A12. Am I clear? These are very basic concept in relative. Just that is A12 means that is the, sorry, here I have to write A1 with respect to A2. That's true. That we have discussed. A1 minus A2. So this is minus A2, this is A1. So A1 minus A2 is this. This is clear, I think, all of you. Can you tell me the magnitude of A12? Magnitude, the vector addition of A1 bar plus minus A2 bar. How much it is? Tell me. Minus A2 bar. This is, let me write this in here. How much this? I've written here. A12 magnitude is A1 square plus A2 square plus 2 A1 A2 cos 2 theta. Why 2 theta? Because the angle, include angle is 2 theta between A1 and minus A2. So that is root over of A square plus again A square plus 2A square cos 2 theta. So that will be 2A cos theta. Just some basic trigonometry. Okay. And initial velocity, how much? At the release time, both are having 0 initial velocity, or initial relative velocity also 0. Okay. S12. So if initial velocity is 0, S12 will be along the acceleration direction because they are uniform acceleration. So S12, this path of 1 with respect to 2. The 2 will observe the path to be horizontal direction, in the direction of A12 only, because initial velocity is 0. Initial U12 is 0. Okay. Initial relative velocity is 0. So this is what I have shown you. This is A12. This is 2. This is 1. This is also V12. This is also S12. So as it moves like this, the minimum distance will be the perpendicular from C to this line. That is CE. Let me call this as CE. This is the perpendicular I have drawn here. Okay. C is the minimum distance between particles 1 and 2. After what time it will happen? After the particle travels a distance AE relative to 2. This is the relative displacement. Okay. So C is the minimum distance AC sin theta between 1 and 2. For this, what should be the displacement? S12. S12 should be how much? AE for that minimum distance. So AE is equal to AC cos theta. Okay. That's true. So AC must be half. Let us see what is the AC. Not AC actually. This is AB. This is AB. This AB length will be half A1 into T1 square. Is taking time T1 to reach the ground. I have written that. So the time to travel AB distance will be half A1 T1 square. That is A1 is A, half A T1 square. Initial velocity 0. Okay. From this triangle CDB is an theta theta. So it's an isosceles triangle. CB must be equal to CD. That's what I wrote, isosceles triangle. And CD is how much? Initial velocity 0. So half A2 is A into T2 square. So CD is equal to half A2 T2 square, that is half A T2 square. Initial velocity 0. ओके अगर CD इतना है हाफ A T2 स्क्वायर तो CB कितना होगा बेटा? दे आर सेम लेंथ ना, तो CD ऑल्सो हाफ A T2 स्क्वायर. ये इंपॉर्टेंट पॉइंट है. सो व्हाट इज AC देन? AC is AB minus CB. That is AC minus CD. CD is same as CB. So AC is AB minus CB. That is half A T1 square minus half A T2 square. Half A common, T1 square minus T2 square. That is AC. I am very particular with AC because मेरे minimum distance है ना, AC sin theta करके निकाल दूंगा. And after traveling, what relative distance that minimum distance will occur? AE. That will be AC cos theta. That's why I am calculating this AC. And remember, AC is half A T1 square minus T2 square. AE is how much? AE, that is the relative displacement of 1 with respect to 2 for the minimum distance. That is AE is half A1 to T naught square. Why? Because U12 is 0. And that time taken is T naught. So that is AC cos theta. AC cos theta है, ये AE है. That is half A12 into T naught square. T naught is the time taken between them, the time taken for the distance between them to be minimum. But that is time taken to reach E relative to 2. The time taken by 1 to reach E relative to 2 is T naught. I have given that. That in question I have written that T naught, after what time T naught? After release will the particles be closest to each other. So that T naught time AE, it must have relatively traveled AE distance, that is U12 is 0 plus half A12 T naught square. That is AC cos theta. That is half A12 तो अभी मैंने निकाला ना, A12 यहीं पर निकाला मैंने. That is what? Where did I write this A12? Here 2A cos theta. That's what I'm writing. Half A12 is half A AC cos theta. AC is this half A12. But A12 is half 2A cos theta and T naught square is AC cos theta. AC is already have written half A T1 square minus T2 square into cos theta. तो क्या निकाल दूंगा मैं? Using equation 2. इक्वेशन 2 में हमने क्या निकाला? इक्वेशन 2 देखो, हाँ A12 2A cos theta. So half 2A cos theta T naught square, that is your A12 is 2A cos theta in equation 2. So half 2A cos theta T naught square is half T1 T2. Here I have just forgotten to write. A cos theta इधर रखा. AE is equal to half A12 T naught square, that is AC cos theta. AC is already I have written here half A T1 square minus T2 square cos theta. And A12 equation number 2, A12 is 2A cos theta. So half 2A cos theta T naught square is half A T1 square minus T2 square cos theta. So A cos theta cancel from both sides. 2 to cancel here. So T naught square will be T1 square minus T2 square by 2. So T naught will be T1 square minus T2 square by 2. Answer to question number 1. So A T naught है. उसमें A is not coming into picture. Suppose it would have been a smooth surface also. Again also it would have been this A is getting cancelled from both sides. Okay. So no problem. So but S minimum में A आएगा. S minimum AC sin theta. AC कितना? AC sin theta. Yes or no? AC sin theta is how much? AC is how much? Half A T1 square minus T2 square. A is how much? A is how much? G sin theta minus U cos theta. Equation 1 से. तो आप लगाओ इधर AC half A T1 square minus T2 square is AC into sin theta, and A is G sin theta minus mu cos theta. So S mean is half G sin theta minus mu cos theta into T1 square minus T2 square into sin theta. T1, T2, theta, they are all given. Okay, and mu also given. So you can calculate the minimum distance itself. न्यूमर के वैल्यू लेके देखते हैं भाई. Okay, T1 9 second, let us say T2 7 second, theta 37, G 10 meter per second square. So T naught how much? 9 square minus 7 square by 2, that is 32 by 2, root over is 4 second. And S minimum is half G sin theta minus mu cos theta, T1 square minus T2 square into sin theta, half 10 3 by 5 minus 0.5 4 by 5, 9 square minus 7 square into 3 by 5, that is 19.2 meters. Instead of point particles, if two, instead को भी मैं ठीक से नहीं लिखा है ना. Instead of point particles, if the two small rigid spherical bodies or disk roll down without slipping, the value of T naught will remain unaffected because A is cancelled from both sides. But S mean will change as acceleration value changes. Yes or no? Will different acceleration value. So S mean will change, but T naught will remain same 4 seconds. T naught value is just I wrote T1 square minus T2 square divided by 2 whole root. Okay. ये समझ आ गया. अच्छा क्वेश्चन है, इजी है भाई, इजी है. मैं टाइम थोड़ा लिया आप लोग साथ, थोड़ा टाइम स्पेंड करने के लिए, थोड़ा क्लैरिटी के साथ बताने के लिए, तो टाइम थोड़ा लिया, लेकिन इजी क्वेश्चन था, मैं मानता हूँ. अभी खुश हो जाएंगे देख के कि चलो सारा आज कुछ इजी क्वेश्चन डिस्कशन कर रहे हैं. चलो ये क्विज है, थोड़ा इजी क्वेश्चन था, लेकिन ये बहुत जल्दी हो जाना है. They will ask only T minimum. You can do in 1 minute. Okay. Second question जाएंगे भाई नेक्स्ट पेज में. Okay, all of you understood this? Go through my video again. कोई मना नहीं करेगा आपको. आराम से जाइए, देखिए, समझ में आ जाएगा, बहुत अच्छा रहेगा आपके लिए. मैं भी खुश रहूंगा. चलो हम पेज 2 में जाएंगे. पेज 2 में जाके देखते हैं. और ये कौन सा क्वेश्चन है, ये देखो कैसा क्वेश्चन है. ये रूफ है, रिजिड रूफ, 2 स्ट्रिंग ऐसे हैं अटैच टू रूफ, एंड ए डिस्क इज you can say heavy disk of radius r rolls down both the strings. ऐसा वाइंड किया है, is both the strings are wound about the disk, and जिसका की रेडियस इज r, ये रेडियस r है. ओके, ये रोल्स डाउन अनवाइंडिंग द टू इनएक्सटेंसिबल स्ट्रिंग्स. ये इनएक्सटेंसिबल स्ट्रिंग है, उसको अनवाइंड कर रहे हैं इन द प्रोसेस. जैसे जैसे रोल डाउन कर गए तो अनवाइंड हो ही जाएंगे. वन एंड ऑफ दिस ईच स्ट्रिंग इज अटैच्ड टू द रूफ ऑफ, देख रहे हैं, द स्ट्रिंग्स रिमेन टॉट थ्रू आउट द मोशन. जब तक वो अनवाइंड हो रहा है दोनों टॉट रहेंगे, लेकिन ये एंगल बिटवीन देम व्हिच इज थीटा, दिस इज दैट विल गोइंग ऑन चेंजिंग. ऑफ कोर्स ओमेगा आल्सो विल बी गोइंग ऑन इंक्रीजिंग लाइक. Okay, at a particular instant of time, the angular velocity of the disk is omega, and the angle between the two strings are theta. Yes, string 1, string 2, theta. Okay. तो अगर ओमेगा थीटा मालूम है तो स्पीड कितना है, सेंटर ऑफ द डिस्क का स्पीड एट दिस इंस्टेंट कितना रहेगा, ये क्वेश्चन बहुत लोग पूछे मेरे को। कुछ लोग एक दो दिन पहले पूछे भाई ये कैसा होगा आप थोड़ा बताइए। मैं बोला चलो मैं वीडियो उसका डिस्कशन कर देता हूँ लेक्चर में। चलो ये आके सोल्यूशन में आ जाएंगे, देखेंगे। ये दो स्ट्रिंग है ना बाबू, 1 और 2 इनर्शियल स्ट्रिंग, सेम डायग्राम को मैं कॉपी किया इधर। ओके, लेट्स से ये इसी डायरेक्शन में मूव कर रहा है, मैं नहीं जानता हूं कौन सा डायरेक्शन है, ये कोई भी डायरेक्शन लिया वी नॉट। ये जो वी नॉट का एंड दिस टू लाइन्स, डॉटेड लाइन OB is parallel to the string 2, dotted line OA is parallel to string 1. So जो V नॉट वेक्टर है बेटा, उसका एक कंपोनेंट रहेगा along string 2 and string 2 is fixed to this, yeah, and there is no slipping, fixed to the roof and there is no slipping. So ये जो velocity of the disk parallel to string 2 रहेगा, from basics of your rolling without slipping, you know that's to be omega r. So let V naught be making angle theta 1 parallel to the string 1. ये V1 जो है, the V naught makes an angle theta 1 है, ये theta 1 कर रहा है किसके साथ, parallel to string 1. theta 2 V naught theta 2 एंगल कर रहा parallel to string 2, ये आप देख रहे हैं डायग्राम में। ओके, सो OA is parallel to string 1 and OB is parallel to string 2, ये भी दिखाया डायग्राम, वही लिखा मैंने। सो ये अगर ये उसके साथ पैरेलल है एंड OB 2 के साथ पैरेलल है, तो एंगल बिटवीन OA एंड OB विल बी एंगल बिटवीन 1 and 2 फ्रॉम बेसिक ज्योमेट्री, हाई स्कूल लेवल ज्योमेट्री, दिस इज थीटा, देन होल एंगल इज थीटा। एंड ये थीटा 1 है पैरेलल टू ये जो V नॉट मेकिंग एंगल थीटा 1 parallel to string 1 and V naught making angle theta 2 parallel to string 2. So theta 1 plus theta 2 will be theta. ये समझ में आता है, बस हो गया। Since disk is rolling without slipping on string 1 and the string is attached to roof of roof, ये कमा दे दो इसमें, roof, the velocity of O parallel to string 1 will be omega r. अभी तो मैं बताया, ये velocity parallel to will be parallel to string 1 will be omega r, because this is there no slipping along this with respect to the string 1 and string 1 is fixed to the roof. Okay, so V naught cos theta 1 will be omega r. V naught cos theta 1 will be the velocity parallel to the string 1. So this velocity, let me write it as V naught cos theta 1, and this velocity I am writing as V naught cos theta 2, ठीक है। So V naught cos theta 1 will be omega r, because that is parallel to string 1, and V naught cos theta 2 will be, that is parallel to string 2, also will be omega r, because omega is a common thing and r is also common. So V naught cos theta 1 is omega r. Similarly, this is also rolling without slipping a string 2 and the string is attached to the roof, component of V naught is parallel to string 2 will be also omega. So V naught cos theta 1 omega r, V naught cos theta 2 is also omega r. So equating both of them, cos theta 1 is cos theta 2, that means theta 1 is equal to theta 2. Okay, so from equation 1 and equation 4, equation 1 में क्या लिखा, theta 1 plus theta 2 is theta, and this is theta 1 equal to theta 2, that means theta 1 equal to theta 2 is theta by 2. बस हो गया भाई, theta by 2, theta 1 equal to theta 2 is theta, this equation 2 में अब प्लेस करेंगे। अभी अगर मैं इक्वेशन 2 में, ये जो इक्वेशन 2 क्या है, यही है ना, V naught cos theta 1 is omega, theta 1 is now theta by 2. So what is V naught? Omega R. V naught cos theta by 2 is omega r. So what is V naught? Omega r by cos theta by 2 is such a simple question. चलो फॉर ए चेंज आज हमने आपके साथ कुछ इजी क्वेश्चन डिस्कशन किए, बट इंपॉर्टेंट क्वेश्चन. आप अननेसेसरी घबरा जाएंगे देख के, भाई न्यूटन लगाएंगे, एनर्जी लगाएंगे, कोई जरूरत नहीं. ये बस कांस्टेंट बेस है, रोलिंग कांस्टेंट, वेलोसिटी का वेलोसिटी ओमेगा का रिलेशनशिप ज्योमेट्री से निकालने का है. इसमें और कुछ भी नहीं है. कोई फिजिकल लॉ मैंने यूज नहीं किया, ना एनर्जी, ना मोमेंटम, ना कोई एनी अदर फिजिकल कंजर्वेशन लॉ, कुछ भी यूज नहीं किया. जैसे कांस्टेंट था. क्या भाई ठीक है? सब खुश हो अब ये क्वेश्चन से? जिन लोगों ने मेरे से पूछा था, नाम तो नहीं ले रहा हूं, ऑल ऑफ यू क्लियर नाउ? Okay, nice that you are now responding nowadays to my lectures. And those who are not subscribed, please subscribe so that you'll get a notification whenever I upload any video, and will interact. Whenever you want to interact, you can always call me in my number, or you can send a message in my number, so that those topics you can discuss. Otherwise, I'll be discussing topic of my choice, which I think are very important for you to learn. So all the best for your upcoming examinations. Have no tension. God bless you. Have a nice day.